Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. And this video today is Day 9, the more difficult Part 2 for the 2021 Advent of Code. This problem is the smoke basin problem. And so Part 1 is already done in a previous video. My puzzle solution to that was 458. Basically trying to figure out which points are low points of our data set. So basically checking to see that numbers are less than everything around. And so part 2 here is once we know we have a low point, like basically that, what do they call it here? That's just a basin. Sorry, that's all it is. That basically I'm just checking to see everything around it. And it's just kind of like a flood fill in a way. We're just trying to flood fill and figure out basically a border of nines are everywhere around us. You can see all of these examples here where everything is bolded and then everything around that is a 9, at least, like I said, not diagonally, but horizontal and vertical. And so you can see a 9, and we're just basically starting from a position, and then we're going to go, hey, let's just check, let's just kind of stretch out to our top, our bottom, our left, and our right, if we can anyway, and say, hey, are you less than 9? And if so, let's just keep adding to it and then add that one's left and up and down and right. The only problem is you have to count for squares or I guess elements that you've already tested. But if you just keep on going and following that kind of procedure and going until you get 9s all around you, then that's kind of what we're doing here. And you'll see here in the code that's how I get about doing this. So this is basically just a modified flood fill algorithm here. So, and then of course, what do I get when I multiply my largest 3 together? You'll see in a second here. Oops, maybe, nope, it's not 1940. I guarantee you that. I guarantee you it's 1940. Okay, so the data is read in exactly the same as it was before for everything. It's a 2x2 array now, or it was. And then now here, I've changed up my get value function from the previous one, where now instead of just sending in an x value and a y value, I pass in a point, or basically an index, a 2-dimensional index. And basically point 0 is the x and 0.1 is the y. And other than that, you'll see that all the code is exactly the same as the previous one. I just made it easier so I wouldn't have to muddy my code down below. So the same thing applies. If the point is outside of the range, it returns a 10, which is larger than a 9. Otherwise, it returns whatever the true data point is. And again, if you know a better way to do this, I would love to hear this. Okay, so then now here is the big difference. Is this code here? Here is my flood fill algorithm. So I'm saying, okay, for every XY position in my data set, and again, there's a lot of data sets to go, or data parts here to go to. And don't mind this, there's no part 3. I just screwed up when I was saving things, and I just wanted to make sure I kind of just had a temporary place to put things. There's no part 3 for this. Aha, wouldn't that be crazy if there was part 3? Don't give them any ideas, Brad. Don't give them. Okay, so then what I do is I say, well, how big is my basin? Remember, like I was saying, what is the size of the number of elements that end up in this thing? This is a 9, that's a 14, that's a 9, and so forth and so on. So my count starts out at 0, and then I put my into my open list. I put my XY value, that's the starting position, and I say the open list are squares I haven't checked yet, and the closed list are squares that I have. And that what makes this easy is lists of lists make this real easy. And as all I'm saying here now, next is while there's another point to check, that's what this is saying, go to see if that point is in the closed list or not in the closed list. Because if it is in the closed list, we don't want to, there's nothing to do because we've already tried that point before and we've already analyzed it. So we would want to fall through. And so we're testing to see that it is not in the closed list, and we're making sure it's not a 9. Because if it is a 9, again, we're done. There's nothing to do when we reach a 9 value. But if it meets both of these criteria, we haven't checked it out yet, and it's less than 9, then we have something to add to the basin. We can say, oh, we can add this to the closed list. And then eventually we're going to either way we're going to delete this thing from the open list. But right now, so we're going to add to the closed list and remove from the open list that same point. But before we delete it, we're going to use that XY value to put and append each of the 4 new positions onto the open list. And again, we can just blindly do that. We don't have to do any extra checks because this algorithm right here will make sure that when we put every element in there, that they're valid and that they're not on the closed list already. But that's all we basically do. We're just put something on the open list, test it out, add things to the open list if we have to, move things to the closed list, and then eventually kick our way out. And so when we do that, we come around, we get our values for how many of these things are set. And then again, no matter what, I'm deleting that first element from the open list. I can do that easily because I know to get in the while loop at all, I needed to make sure that there was at least one element anyway. So I get rid of that, and then I basically add it to the closed list, keep on going. And when I fall out of this thing, I have 2 things. I have a closed list full of points, which is basically the length of, if you want to think of it that way, I guess I didn't even have to do the count plus 1. I'm afraid to try it. I'll try it after I'm done with this video. But basically the length of the closed list should hold all the values, because it has to, because this thing works for me. So I can absolutely do it, but I'm not going to do it until I'm out of here. So you can tidy this up a little bit. But for every element in the closed list, I go ahead and set it equal to 9, so that because the rules say that once every low point, whatever this collection is, because obviously there's only this basin can only be part of one thing. But if I'm testing every XY value, I don't want to be testing the same thing over and over and over again, because this value right here will give me the same value of the same basin size as this value the value right next to it. And I don't want to accidentally put too many things onto my basin list. And so I set all those, I change the data under the hood there, and I say, okay, if the count is greater than 0, because it is possible that you're touching a 9 and nothing gets advanced, so the count could be 0, that the basin size gets added onto this thing. And I'm just doing this over and over and over again for every point. And then now I take the basin values as they're done, sort it high to low instead of low to high, as is the normal way to do things, and multiply the top 3 together in 38 lines of code. And when I do so, I get myself that number, which is exactly the number I'm expecting to see for my solutions. So there you have it. There is my solution for part 2. Not as crazy as last night's. I was just tired. That's why I didn't get that one as quick as I had liked to. It was right in front of me the whole stupid time, but I didn't see it. But now, of course, looking back, I go, duh, it was right there. The 1s and the 4s could have got me everywhere. So thanks for sticking with me on this video, as always. If you have any questions, or if you know a better way to do this, please comment below. I would love to hear it. Well, thanks. I hope to see you guys in day 10. I hope day 10 is something completable in a reasonable amount of time, as finals week is coming up soon. I got to get to other things, obviously, with my students and my stuff in my real life here. Have a great day, everybody. Have a great night. Have a great everything. Have a great day. See you later. Bye-bye.